AI Game Changers podcast with Luke Whips.
I don't know if you want to take us back as far as you can before all of the cool stuff started happening with TUM and the Indie Autonomous Challenge and stuff. Like, where did your entry to artificial intelligence start? And how did this all begin for you, man?
Yeah, so basically I think if I go back, my entry into AI was a little bit, let's say, unstandard in the sense that I've come from a very applied way of entering engineering. So I did what's called a cooperative study program in Germany. So how that works is you work part-time for a company and you do study part-time. So that was my bachelor's program. And when I was doing that, I was working with a company which is in agriculture. So I was working on automation of combine harvesters. And basically, so I started very, very hands-on and then eventually moved more into the academic sector, doing my master's and then eventually starting at TUM with the autonomous driving challenges. So back in 2017, we've been starting quite a small team, which was 4 persons initially. So it was December 2017. We had 4 persons and we had that huge challenge in front of us going with a full-scale vehicle on the Berlin Formula E track just 5 months ahead. So that was 4 persons, 5 months ahead, and we were basically starting right from scratch. And that was my, let's say, big entry in all of this autonomous vehicles, AI, and these kind of things. And once we were able to achieve that demo in Berlin, we eventually built it from there. So starting with the RoboRace races, this LMP2 prototype, we increased the team up to 7 people. We then started entering the Indie Autonomous Challenge, which was more university focused, so more research focused as well. We grew the team up to 15 people. I got promoted to be the team leader of the Indie Autonomous Challenge team. And then we eventually ended up winning in Indy. So that has been roughly the sum up of my four and a half years at TUM. And so that's how I got into AI.
Yeah, awesome, man. I guess how did you even discover the Indie autonomous driving team? I know it's quite well known in the autonomous driving world, right? But I guess coming from an agricultural background, you must have seen that at some stage and thought, shit, autonomous cars are way more exciting than combine harvesters, right?
I wouldn't necessarily say that. So let's say that the technological challenge is pretty huge in agriculture. So there is a ton of interesting stuff to work on. And actually there's some AI involved. But I think my way into the racing thing really started when I was doing a Formula student back in my bachelor. So I was a part of a Formula student electric team. We've been designing an electric race car from scratch. So basically designing every single bit on this car. So designing the monocoque, designing the aerodynamics, designing the motors, everything. So that's very kind of a hobby for racing, for motorsports, evolved into kind of my, let's say, there was this opportunity to joining the racing team with autonomous racing, and that kind of gave me the chance to combine automation and racing, which were 2 passions for me. So it's one of the most complex environments, so it's quite nice challenge for applying artificial intelligence algorithms because it's super complex, it's super dangerous. So if any single thing goes wrong, you basically wreck a $1 million prototype, which is quite thrilling. So,
wow, man, that's some pressure, right? Especially, I mean, how old were you when you were working on that?
I think I started when I was 25.
Wow.
So now I'm 29.
Yeah. Wow, man.
Could be worse.
Yeah. £1 million potentially crash site in your hands at 25 years old. That must be some pressure, dude.
You do ramp up in the terms, having the most expensive thing that you ever crashed in your life, or broken. So that's kind of an interesting question for people. But that's one of the good thing about motorsports. It's motorsport vehicles are built to crash. And that's why this environment is so well suited for the development of autonomous driving at the edge. Because basically if something goes wrong, those vehicles are built to crash, the tracks are built to crash, so it's super safe, no one gets ever harmed, and basically it is an invest, but compared to the money you do spend on human resources, just on all the research investment you have to put into the yeah, those are actually pretty small. So it was quite interesting. Back to me, it's like people are super crazy about this. Oh, what does happen if you crash? I think eventually, like, we didn't burn more than like a small 5-digit number. So, and that was for like a couple of years. So you do have to live with that risk, and it does happen eventually. But yeah, it's not it's not the end. And like comparing that to a research program running 15 PhDs for like a couple of years, that's like really small money. So it's kind of worth the investment.
Yeah, for sure, man. So you guys obviously won the Indie Challenge, right? Which is awesome. I bet that must have felt amazing. But maybe if you could kind of take us back to the beginning of that, because I think you mentioned that when you first joined, you had 5 months until you were going to put a road on the Berlin track, right? So that's obviously a super short period of time to be working on something like that, right? So maybe take us back to the beginning of that and just give us an overview of how you started kind of formulating some kind of plan. I can't remember how many team members you said you had, 4 or 5, but I mean,
it was 4 in the beginning.
Yeah. So
it was pretty small.
Yeah, so that's a super small team. 5 months till you need to be on the road. I mean, how did you do that?
Yeah, I think there have been basically, or like the key trade-off in all of that has always been like, how much do you invest in kind of like long-term things like simulation tools, infrastructure, these kind of things, and how much do you invest in kind of like the algorithmic feature development? That's probably, let's say, the hardest and the key trade-off you have to make in all of those projects. And I think basically what was like key to our success, even back then, having only 4 people in the beginning, was a significant investment in simulation. So right from the start, even though we were a super small team, we spent a lot of time on actually building the tools to get it right on track. So we like always optimized for on track time, in the sense that we spent like days and days and days building the right simulation tool, and then be super sure what we deploy on that car is actually going to work. Because like if you have a test day with those cars, it's like so back in the days in RoboRace, it was like there was still a human driver in there. So we have been driving up to 100 kph with safety drivers. So if something has gone wrong, there was a chance for like the driver taking over and bringing the car back to the pit. But you still lose like a 30-45 minute slot, like from stopping the car, bringing it safely back to the pits, evaluating on what's going on. And if you run on like a racetrack, it's like you have like 8 hours a day. So you basically got like 10 to 12 of those slots. And if you mess up like 3 or 4 of them, even though it's only half a day, it's like given your total testing time, it's really a lot. So we've been investing heavily in simulation, virtual validation right from the beginning. And I think that was like key. But obviously, having only 4 people, what is crucial is being super focused on what you want to achieve. Don't get like caught up by all the interesting stuff which is on the road. Be super focused on actually mastering the task. And I think one of the challenges, especially in AI and in research, is there's a ton of things which are interesting to explore, but it's very hard to get that validation from the like actual engineering task you're trying to solve. I think that's something we're also seeing like in a broader way in automated vehicles, but also in other areas where AI is applied. Like people have to focus on business value. We did have to focus on race performance, but which was kind of the business value we had to provide. And that's kind of hard to measure, especially in like early research stages. And if you come there with research mindset, it's like, I just want to do the craziest and most advanced algorithm I want to do, but that's probably not going to fit into your timeline.
Yeah.
And you probably don't know about like the 25 things which will go wrong, which you have never thought about. So if you just lay out the timeline, don't accounting for all the small things which will go wrong, you are eventually screwed.
Yeah, so I do a lot of recruitment in autonomous drive, and I always find that the people that come from those Formula student kind of backgrounds that have worked on something like what you guys have, it builds such a strong foundation of not necessarily having the kind of like business outcome or the understanding of how things work from a commercial standpoint. But from that delivery perspective, people really know how to apply stuff and use the skill that they've got to actually, deliver projects rather than just understand the academic, the academic foundation of how things work, right? So yeah, I find that it sets people up for such a great career if they've done something in the wild that, there's high pressure, high working, pressure, generally speaking. And I always see that from the Formula student teams. That must have given you quite a good foundation to kind of found Driveblocks, right?
Yeah, and I think actually that's quite interesting, but running a startup is, there are some quite strong similarities. You usually start with a small team, you have to be super focused on what you do. But as you said, like having this like experience in delivering projects on time, so you get super used to that in racing, because basically there's race day and it either does work on race day or it doesn't. And it's pretty much the same with business. So there's like, there are these deadlines where your clients, your partners and so on are, demanding or like expecting some kind of delivery. And it is either there or it's not. And it's basically like, and I think that's kind of like thrilling about those small companies as well, which is like you really have to deliver those kind of things. And you can't like hide behind the big organization where you're in. So it's like, it's you and a couple of others, which are pretty much all in the same room, and you either do it or you don't. So
yeah, did you guys ever get to race day and something go critically wrong and it not work, or did you guys have a pretty fair run?
Yeah, I think we I can like think of two major things which have been happening. So basically like that Formula E race in Berlin back in 2018. So after this 5 months of like initial development, what was happening is basically we've been there in front of 15,000 people on the stands. So that car out there on track. So the commentators saying like, these guys from TUM are going to run that car. And then it didn't launch. It didn't start driving, just.
Fuck.
And there was no chance by connecting that laptop onto that car. And it was pretty clear that some kind of like sensor or something wasn't working properly. And then you're there having a ton of people. So basically you have to make a call on what you do. And we like eventually just disabled kind of a couple of parameters, changing them just by guesswork, and it eventually solved the problem. So, but we didn't have any chance to like see what is actually going on. It was like, okay, it could probably be this sensor which is broken. So if we deactivate that algorithm is probably going to work. So that was kind of a thing.
How did that feel?
It's a ton of pressure, and I think what was for me always the most or the hardest part about those situations, it's not about what the outside thinks. It's a lot about like all the team members put in a ton of pressure, and then someone at race day has to like call the shots on those things. That's a pretty tough situation. And I think we had a similar situation in Indy where we have been like on race day, there was a question whether a part of on that car is going to work correctly. And then someone has to take that decision whether the algorithms are like, should take information from that part or they shouldn't. Because eventually for that part, there wasn't like an online diagnostic. So you have to like decide. And that's for me always, I think the hardest part was having seen that a ton of team members put in like months of work into this project. And then, it's like such a tiny little thing, but that's the same as you see in F1, right? So it's like always the small and tiny things which break race cars. It's like a screw here or like a loose center lock there. So they lose a tire after like a pit stop or stuff like that. And I think that's also the thrill of racing because it's like, even though it's technically super complex, it's still a lot of human involved. And probably circling back a little bit on that, that's an interesting topic because I've got asked several times about whether autonomous racing is actually a sport. And I do believe it is. It is not a sport from people being in that car, but it is a sport of the teams running and operating those cars. So the focus really shifts more towards the engineering team, and it goes away from the driver. So that's different, but there is a lot of human involvement. There is a lot of strategy involved, like how much risk are you going to take? How do you want to position yourself? Like, because it's always like, okay, there are like kind of a couple of risk parameters on those cars, like what's my top speed, what's my like aggressiveness in corners and these kind of things. And it's like being a race engineer talking to that car saying like, you should go all in on that run, and then the car goes all in on that run, but no one tells you whether it's going to work or not. So
well, it's kind of like, it's a digital athlete, right? Because if you think about what a human athlete is, it's mind, body and skill, right? And I think if you broke it down really simply, that's essentially what happens in an autonomous vehicle, right? Do you think if you were going to put the percentage on what's the most important thing out of those three topics, what do you think is the most important thing of an autonomous vehicle?
You mean from mind, body, and skill?
Yeah.
That's an interesting one. I would probably translate, let's say, body to be, let's say, the general hardware setup. Mind is probably like the compute, and skill is like your algorithm, what's in there. I actually think the key is that all of the three fit together. It doesn't help you have one thing being super strong and being super advanced. It's all about matching those things. And I think that's also a challenge which the AV industry is facing these days. It's like understanding how can we bring computer science, vehicle technology, and like all of those electronics and safety challenges within one product. Because it's not like, it will not be solved by just applying the same strategies as we do in like cloud computing. But it also won't be solved by applying the same strategies from the automotive domain, where like companies like the big OEMs like Volkswagen or Mercedes have been really great at like building those vehicles, but also they have to adjust their strategies. And I don't think that like super secret recipe has been found yet. And that's what everyone is chasing.
I guess that's where Driveblocks steps in, though, right?
Yeah, I do believe that we have, like seeing our history, we have quite some skill in bringing these things together. That's probably one of our strengths, being like, or having worked in all of those different areas, or having seen the challenges which come with the different areas. And I think what has always been important to us is to match them right from day one. So don't develop like for years and years and years just in in a computer science way, and then go onto the car or on the vehicle and realize it's not going to work. But having this like exchange between the different disciplines, I think that's something which is super crucial, and what we can bring to the table.
Cool, man. Well, look, I guess just because you guys are super new, right? So I guess for the listeners and for the people who don't know Driveblocks, what you guys do, maybe can you give us a high level pitch and just give us an overview of where you've gone? Because I think the autonomous driving world and industry is fairly noisy. I don't know if that's the right word to describe it, but there are a lot of things happening, right? And there are a lot of different approaches and different angles. So maybe can you give us an overview of Driveblocks and where you guys kind of fit in that noise?
Yeah, so I think, so probably to sum it up, what we do is, we develop a software framework with autonomy algorithms. So we do autonomy algorithms for object detection, prediction, planning, control. So it's broad in the sense of autonomy algorithms, but we are super focused on building those autonomy algorithms. So we don't build like full vehicles. We don't build an operating system. We actually focus on the different aspects of the driving task. So understanding what's going around, what's going on around the car or the vehicle, understanding what the vehicle wants to do. And that's like the key focus of our work. So what we think is, I think that's probably key, is we believe that there's going to be an ecosystem of different partners solving that challenge, rather than seeing like a super integrated solution, like a couple of players are doing that out there. So I think that's probably, like, if you look at that from like a really broad perspective, that's how you can see the AV industry. It's like the companies are trying to vertically integrate and having every single bits and pieces of that technology under their control. And we do much more believe that there's going to be an ecosystem of partners, like a couple of people like delivering the operating system, delivering the sensors, and other people like us delivering the autonomous driving functions. And from this ecosystem, we think that vehicle manufacturers can like take the bits and pieces which fit their task the most, and then actually build products from that. So we see ourselves as a framework provider. So developing a framework which is then going to help the OEMs actually solving the autonomy problems. And from a application point of view, we look a lot into commercial vehicles. So our focus areas are container logistics, mining, but also eventually hub-to-hub logistics. So these are like the key 3 areas we look into, but we also see that this like modular partnership-based approach opens up a couple of like new opportunities. So for example, sensor manufacturers who want to add intelligence to their sensors, or like steering motor manufacturers who want to make their steering motor more intelligent and more integrated with the like autonomy function. And that's one of the strengths of this like modular software focused approach. There are like a couple of ways how that can be commercialized. And I think that's the summary of what we do.
Yeah, so you would typically work with what, OEMs and tier 1, tier 2 suppliers? That would be your kind of target market, or what kind of clients do you typically work with?
Yes. Yeah, I think it's like kind of like a software company probably working together with a tier 1 on system integration or directly to the OEM. It depends a little bit at the moment. So I see that those relations are not super clear. Like a couple of the OEMs try to do things which have been like historically done by the tier 1s and the other way around. So that's kind of mixed up at the moment. But I think what's super clear to say is that we provide a software framework which can then be integrated by either the OEM or the tier 1 into a like autonomy platform, including hardware, sensors, and these kind of things.
Gotcha. Right. I guess this might be a bit of a challenging question, I guess, but what I know about tier 1s and OEMs is to work with those kinds of companies. It's a bit of an uphill battle, right? Especially with a new young team that's first step into kind of the world of production, right? So, I mean, I guess because you've got 2 challenges, right? You've got the challenge of actually building your market presence and actually building a client base that you would work with, right? And then on the flip side, you've actually got to solve the problems that you're trying to solve as well. So how are you finding that challenge, generally speaking? And secondly, how are you approaching that? Like, what are your first principles in your approach, both from a customer perspective, but also from a technology standpoint?
So, I think that's always what people, let's say, are concerned about in the automotive market. I was actually quite surprised on how open those companies are to work with startups. So I think there's like a change of mindset. So there are like kind of different models. So for example, a couple of companies start also investing in startups, which they believe are like interesting technologies. But there's also this approach, which is called venture client approach. So basically what you do there is kind of a company-based accelerator, like a startup accelerator, like sponsored by a company. And the interesting thing about that, it's not only about like providing you money, they do actually buy products from you. So they move into a role of an early customer, and that does help you a lot to like validate your customer interface and these kind of things. So there are a couple of companies who are doing that these days, and also like in the automotive sector. But obviously, like as soon as you have those big size differences, there's always like a slight clash of cultures from time to time. And so, but I think that's also something, and we really enjoy those relations because there's a ton of stuff we can learn from those folks on like how to commercialize and industrialize those products, because it's a totally different thing in building a single race car and making that autonomous, and operating a fleet of 10,000 or maybe 100,000 of vehicles. And so I do think there's like value in both perspectives. Probably the last thing to add here is that I believe our like track record on the Robo Race and Indie Challenge really helps with those situations, because it's actually like we have been proving that we can do that, and we have been operating that under real world conditions, and I think that's really sets us apart from other young companies in that area, because just like getting there is like a super hard journey, which takes time, money, and these kind of things. And having the chance to do that during our PhD time at the university is really was a really big like boost for starting that company, because it somehow gives you like a some kind of credibility, which
right?
is quite important if you start working with corporates.
Yeah, for sure. I mean, that credible aspect that you guys bring to the table is going to be quite profound, right? Especially with the added prestige of TUM. I mean, you know, if you've got those two things lined up, that's a very good platform to be able to work from, right? But I guess there must be some differences, though, right, in terms of what you did at TUM and in the Indie Challenge, because, you know, there is pressure there, but it's kind of like different pressure. Whereas in the kind of commercial world, you've got business expectations, right, in terms of delivery. And do you find that there's a difference in terms of pressure, or do you feel like it's the same kind of thing but just packaged up slightly differently?
I think from like the general pressure perspective, there are a lot of similarities, but it's different drivers for that pressure. So in research, you always have this, like one of the challenges we faced is like, we want to be great at the races, but we also want to do great research. So work on in like advanced algorithm, try out new concepts, be innovative. But usually if you try out something new, it's going to degrade your performance first until you like eventually come to a higher level. So that takes time, it takes resources, and you have to also balance that within the team. So you can't like deploy new approaches on all bits of the software at the same time. You have to do that like eventually and these kind of things. But that was purely let's say innovation and performance, or like technology performance driven pressure. And if you look on the business side, there's a lot of like cost pressure as well. So what we're really seeing, I think, these days in the AV industry is that we're moving away from these like tech demos and entering a phase where we are like actually we are either going to deliver products in the next 2 or 3, 4 years, or I think there's really going to be like a longer downturn of the market. So there's really a lot of pressure at the moment to like get certification right, to get the cost structures right, to get sensors working in level 4 applications, which will be like, so fully autonomous, but still automotive grade, safety certifiable, these kind of things. And I think probably the two biggest difference are the like safety certification part and those cost drivers. Because even though we had like really good reliability numbers on the racing part, so I think we just crashed one car by a software fault, which is okay in 4.5 years. So, but so we're really like, you know, not all of the software has been developed to a standard which would meet like the expectations of like the TÜV, for example, who's certifying those vehicles to be brought into production. And that's probably the largest challenge everyone faces at the moment, making sure those things are not only functioning, but they're functioning well enough and they can be certified.
In terms of your mindset about your work now, Alex, what's been the biggest transition for you coming from university into business? I know you was just talking about the kind of safety aspect and kind of getting to grips with that, but just in terms of how you approach problem solving and what you do, what's been the biggest shift for you?
Yeah, so I think historically I've been super focused on identifying the core parts of the technology challenge. So I was always a person like trying to push towards let's try the hardest and most complex things first to see whether they work, because if they do work, we can like solve the rest, and that's like an easy thing. But if we see that they don't work, like, you know, we probably have to change the overall concept or the system architecture or these kind of things. So that has been kind of my approach at the university. And I think what I had to do in the last couple of months is actually to switch that to like validate towards customer interest first. And that's probably the most important thing if you're building a company, like understanding what's actually the need of the customer and like what's that sweet spot on what you can deliver, where's the value you can add, and don't get like caught up in, let's say, the nice and hot technological challenges, and really like find that sweet spot between technology, business, and certification.
So how does that look from kind of like a day-to-day then? Like what changes in the way that you operate as a person? Because I'd imagine if you're coming from that angle of, real technical depth, and as you say, wanting to work on the most complex challenges, that must be quite an active thing because that's probably your natural state of flow, right?
Yep.
So it must be quite an active thing to be able to transition over and think, oh, actually, let's take a step back and think about how is this going to impact our customers, and is this actually what they care about, and is this actually what they want?
Yeah, I think, how that looks like is really, so like back at the university, I was really like focused in doing this kind of analysis, also from a high level point of view, like as like a system architect, team leader, you get quite a broad picture, but it still tends, so the interesting thing is it's still a lot about communicating, but back then it was much more like to the inside, talk to the people, understand where their challenges are, and try to frame them in like the big picture. And that communication really has shifted to the outside. So that's something I'm like actively looking for, to get into exchange with people from like partners, customers, also or just people within the industry, to get their perspective on what they believe is going to be like valuable to them, and also what they believe how the industry is evolving. Because I really think, and that's why I think autonomous vehicles is one of the like greatest industries at the moment to work in, because it's like it's not clear where it's going. So it's super hard, and it's not only super hard from a technological point of view, but it's also super hard from a business point of view. So making that a profitable business is, it's like a huge challenge in itself.
So how do you guys think you're going to win? Because I don't know if you keep up to too much with like, layoffs and close downs and stuff like that, but obviously I do. And I mean, especially over the past 2 years, because of obvious reasons, there's been some turbulence in the autonomous drive market, right? How do you guys win the race of what you're trying to achieve, and what do you guys bring to the table that you think is unique or sets you above what's currently on the market today? That's probably quite a difficult question, so if you want to take a stab at that in a couple of times, then you can rock and roll.
Oh, that's fine. I think I would just like, split that into like the kind of like technological approach and the kind of business approach. And I would like enter the tech part first, and then go a little bit more into like the business perspective on how we see that. So from a technological part, I think there are two key challenges at the moment which we want to tackle like in a certain way. So the first is, so we believe that it's like super crucial for scaling to don't rely on super high definition maps. So there's still the question on like how detailed those maps have to be. So you definitely need maps in terms of like a navigational layer and these kind of things. But I do believe that it's like, as long as we rely from a technical point of view on like centimeter accurate maps, we will have a ton of challenges in actually making this a profitable business. Because we'll have to remap like basically on a day-to-day basis on like as soon as you run on public roads. And yeah, we see that as like one of the key cost drivers. So that's something we are really focusing on at the moment. So yeah, making the technology robust enough to like run without those high definition maps, or just rely on very sparse, a lot less detailed maps, which are much easier to like maintain. Actually, they do have to be maintained by the vehicles themselves. So
what are the
and the second part is,
sorry, Alex, let me just quickly jump in there. When you talk about
go ahead.
The kind of low density maps, right, and not centimeter accurate kind of mapping, what's the downsides of using fairly sparse mapping technology? Because there must be some trade-offs, right?
So I think there are like, what becomes harder is like integrating stuff like fuel efficiency and these kind of things. So where you really need like a long-term understanding of what's going to happen in front of you. But we believe that's something which can be solved by finding like the right detail level. I think probably the biggest downside is to get the reliability part right. So just imagine, for example, if you run in kind of like a snowy environment, which does happen in Germany, so from time to time, and so getting like the road network structure from a road where there's snow on top of that's something which is super hard, and which is where you really need advanced perception algorithms. You have to like understand what other vehicles in front of you are probably doing. You can't rely purely on lane markings. You have to take into account other stuff like barriers on the side, having some kind of like a common sense about how lanes are built. So I think getting that right, especially in harsh weather conditions, is kind of like the biggest challenge. And also it's probably the reason why a lot of people say, okay, like at least for our go-to-market strategy, we're going to rely on those maps. Because basically they do help you a lot as long as you want to like start building like real operations as fast as possible.
Cool. And so the upsides of those maps, as you say, are so can you just go into the upsides just so I can get a good understanding of kind of the balance between the two?
Yeah, I think the upsides really is that you get a lot of reliability, which you don't have to build by like local perception tasks. So you can start like, pre-planning certain trajectories really along that structure and these kind of things. And you can eliminate a lot of noise from like, so one of the challenges, for example, is, so just imagine you want to like see in front like 250 or 300 meters. And if you want to do that like purely with cameras and laser scanners on that vehicle, that's kind of a hard challenge because you have like 2D images and you have to get an accurate 3D representation of the world around you. And if you use maps, that does help you a lot because it does have this 3D representation, which you can correlate with what you see on your camera images and these kind of things. But we're seeing technologies like stereo vision or multi-camera vision like evolving and actually helping to overcome those challenges without having to like pre-map the situation or the operational design domain where you're running. So I think really the key upside is reliability, but you pay that with a lot of cost in terms of scaling because you do have to like map those things daily. And often the vehicles you have in your day-to-day production are not equipped with the sensors which can do the mapping because they are not precise enough. Because you want to use like lower cost sensors on your like, large fleet. So you have to have like extra mapping vehicles and these kind of things. And that's hard from a scaling perspective and scaling will be like, I think eventually will be the key thing when moving from tech demonstrations towards real business cases.
Mm-hmm. And I think you were going to mention just about the business side of your focus now. So yeah, sorry to kind of dive in there, but yeah.
No, that's fine. I think from a business side, we believe that this like software framework approach opens up kind of like a nice scaling opportunity because it doesn't require you to have like a fully certified system from day one to do actually commercially viable applications. So there's like a ton of opportunity, for example, in also like deploying parts of those algorithms already in advanced driver assistance applications. There's opportunity in doing stuff like emergency braking assistance, these kind of things. But there's also opportunity in already chiming in at quite an early stage and actually be involved in that development and be like a partner which provides you with like a software development kit rather than having this like, okay, here, take my black box and either you like it or you don't approach. So we really see that much more as like a partnership-based approach, where we enable our customers. And I think, and that's probably the other part why that makes sense from my perspective, the software side is right now one of the like largest cost drivers in development. And if you're able to like cross-validate amongst different applications, different use cases, that's really going to help you up your reliability. So I think these are the two ways we see why this, and that approach is not really common, like having this like software-only approach. And that really sets us apart and opens up kind of like new ways of how vehicle manufacturers and startups can work together.
So if we were to fast forward 5 years from now, what does Driveblocks look like?
So I think like looking at 2027, we envision that we have like a commercially operating software stack, which is running highway operations. So I think the hard part is on like how that commercial scale looks like. But we do believe that by 2027, we'll be in a situation where we can operate a full software stack on highway-like situations for like semi-hauler trucks. That's pretty much like the vision for 2027. I think the hard part will then still be to scale that up. And that's something which is up in the air, how fast that scaling can go. But we definitely believe that in the next 5 years, we are going to see companies actually bringing that into business, and we believe there's a chance that we can do that.
What about the roads in general, man? Like, do you feel that the kind of traditional method of driving now will eventually become redundant, or do you feel like it will be a hybrid thing?
You mean in terms of like personal driving? These kind of things?
I personally don't want to lose my car, but I also want to have an autonomous car. I think one of the reasons why we are really focusing on this commercial side is that we don't see people actually like not driving anymore in the next 5 to 10 years. So I believe there's going to be a long time where hybrid situations will be there. I think it's a different thing in the commercial vehicle industry sector because there's like driver shortages and these kind of things, which are really like drivers for change. But if you look into that robotaxi market, there's like, really other dimensions to it. So you have all of this, like people trust, you have people, having fun driving their cars and these kind of things. So I personally don't see people privately owning autonomous vehicles. I don't think there's like a business opportunity to that. I think from the robotaxi perspective, it will eventually be much more of like a mobility as a service approach, where like taxi companies will offer you super low cost rides between different areas, and seeing these trends to, I don't know when you have been last time to Munich, but Munich is super crowded with cars. It's like a mess, and you can't really get a parking spot for your single private car. So if you want to have an autonomous one and like manual one, it's probably going to be you pay like the same amount as like in other towns you pay for a rent just for a parking lot. And so I believe this kind of like mobility as a service things will be like the way to go for autonomous vehicles. Awesome, man. Well, I'm looking forward to the future. So it's going to be an interesting couple of years for sure. But Alex, I guess that's about it for today, dude. So I mean, thank you so much for your time today. It's been an absolute pleasure to speak to you. And I mean, it's super inspiring to see a young startup kind of kick off and get going. So honestly, dude, I wish you guys all the best. And I'll be tracking your journey intensely on LinkedIn.
All right. So thanks, Luke, for inviting me. Yeah, it was really great, and looking forward to stay in touch.
Awesome, man. Done.